Hello! Now we're going to focus on the Earth. How exciting! So first we're going to go through a few things that you might think are kind of basic, or maybe you haven't thought about them in a while. And I think it's kind of interesting and amazing to think about our Earth. The big takeaway from this lesson is that the Earth is an exact location from the Sun to have all the features on Earth as we know it. So if the Earth was just a couple thousand miles, or even 100 miles farther from the Sun than it is, we would not have the life that we see on Earth. Maybe we would have life, but it might be quite different. We wouldn't have the habitats and processes and vegetation that we have on Earth. It's very amazing that we are in such a perfect location. And because it's a perfect location, it's often considered the Goldilocks zone, meaning if it was a little too close to the Sun might burn off the atmosphere. If we were a little too far from the Sun, it might be very cold like it is on Mars, and we wouldn't have the atmosphere to actually insulate the Earth and protect it. So we're going to look at where the Earth is in the solar system just a little bit, but mostly we're going to be focusing on Earth itself and different processes that go on Earth. So the first thing to think about is Earth spinning on its axis. So the axis is a fixed location, a kind of a line drawn through Earth around which the Earth rotates. So I have a globe here, and we can kind of look and see. So the axis is what it spins on. So which way does Earth spin? It's not something I usually think about, but it's actually important in terms of how the ocean currents circulate around the globe and how different air currents circulate around the globe. So it's actually important which way it spins, and we can figure that out based on observations on Earth. So we have sunrise in a certain direction, right? So let's pretend that my head is the sun, and let's spin the globe. So it goes in a counterclockwise direction. And that makes sense because if you see, let's see, where is North America? We see North America coming up here. The sun is going to affect North America as a sunrise right when it gets around this corner. So the sunrise is on the east coast of the continent. So that's actually useful. Another thing that I think about is when we watch the New Year's fireworks, a lot of times they show fireworks and it's nighttime and it hasn't even gotten dark for us yet. Who gets the fireworks first? Usually they show Sydney Harbor. They show the Opera House, the bridge. So this is on the east coast of Australia, right here. So Sydney Harbor, they're experiencing the New Year before we are. So they are having the New Year and then we get the New Year. So we're spinning counterclockwise. How long does it take to rotate around the axis? 1 day, 24 hours. So we've got a rotation every day. And what I think is interesting is that is the only thing that gives us nighttime. Nighttime is just when the sun is on the other side of the Earth. So something important about the atmosphere of Earth is that during the day, the atmosphere, which is that layer of gases and water vapor that protects Earth from space, the atmosphere is soaking up sun energy and trapping it with the gas molecules so that when it's nighttime, we don't completely freeze over. So if we didn't have an atmosphere, every single night it would get so cold that life could not live on Earth. So the atmosphere insulates us like a blanket at night, even though it does get cooler at night usually because we don't have direct sunlight. It keeps some of that heat energy so that we can survive overnight. So something else that's interesting about Australia is they have totally different Christmas traditions. So this is a postcard in the upper left corner from Australia, and some of their traditions are to go to the beach, wear the swimsuits, go surfing, play lots of outdoor sports, have a picnic, have a barbie or a barbecue where they make a lot of seafood and shrimp. So it's like a seafood season. Everyone's out fishing. So it's very different traditions. And this is because in December, the Australians are actually having their summer season. So their Christmas break is essentially summer break. They have a huge summer vacation that includes Christmas. So much different culture there. So how is that possible? What makes the seasons happen? That's our next question. So you notice on my globe that this axis is not straight up and down, it's on an angle. So this is Earth's tilt. It's actually a pretty dramatic angle. It's not just a small amount of tilt. It's about 23.5 degrees of tilt. So that's a lot out of 360. So the Earth is actually tilted, and that means that if my head is the sun, a certain time of the year, the southern hemisphere is tilted towards the sun. So this is showing that. So as, I'm going to try to get in the middle of the frame here, as the globe is rotating around the sun, we can all agree that the globe is rotating around the sun. It's kind of hard for me to do that with my head. But as we do that, the Earth's axis stays at that tilt. So as it rotates around, now on this side, when it's on this side of the sun, the northern hemisphere is tilted towards the sun. We can see North America up there. But as it goes around, on the other side of the sun, now the southern hemisphere is closer to the sun. So we've got Australia there, South America. So if you ever have, or Africa, South America. So if you ever plan a trip to one of these places, keep that in mind. It might be a totally opposite season, or it is a totally opposite season in the southern hemisphere. So that means, and here's an image showing this, the tilt stays the same while the Earth is orbiting the sun. The Earth does orbit around the sun about every year, right? So half the year it's closer on one side than the other, and then there's a transition period, which is spring and fall. So that's kind of what I'm talking about this Goldilocks zone. If you think about most places on Earth, there's a dramatic difference between summer and winter. So that dramatic difference is not a very far distance difference from the sun. It's just caused by this small amount of angle of tilt of the Earth. So I think that's very mind-blowing. That's all that causes the seasons. So here's another image that shows the Earth orbiting the sun. And so at one point, the southern hemisphere is closer to the sun. And at another point, the northern hemisphere is closer. So this also explains why the seasons are not as dramatically different at the equator, because the equator is usually around the close part of the sun. But the farther you get from the equator, the more dramatic the temperature difference between the seasons. So the orbit around the sun is not exactly 365 days. It's 365.25 days. So that is why we have added into the calendar year a leap year every 4 years to add an extra day in February. So all that stuff is kind of arbitrary. I was reading in the book recently about the names of the days of the week. So we kind of made up that there's 7 days of the week. But we didn't make up the length of a year. The 365 days, that is actually a thing, because a day is a rotation of Earth, a spin of the Earth on the axis, and it does take 365.25 days to go around the sun. So that's all I've got about the Earth right now. Stay tuned for more videos.